This video continues from the previous. Okay, solar orientation. What does solar orientation have to do with residential building design? Well, where the sun is has an impact on things such as solar gain. How much heat is the building absorbing during the day, and how much is it later releasing at night as a result of that? And so what you can see in the bottom there is for some sun angles at different times of the day, where that position is in the sky, different times of the year. And by knowing this, it will help us decide how wide to make our overhangs to either block summer sun and help create bounce divert light, or to make sure that winter sun, especially in our colder climates, is getting in, and possibly in some cases it's getting in and being collected in floor systems to later radiate out at night. Like say you're working on a project in the desert. You want that because it's colder in the desert at night. So if during the day you're going to collect the sun, and there are systems, some really cool systems where the floor is tile, radiant tile or stone, and beneath that are water tanks. And so this all absorbs the sun during the day, and then at night it releases it. So our overhangs are going to matter on how much sun gets in, dependent on whether we're in the summer, spring, winter, or fall. Therefore, the first step in designing how we're going to orient our building is to consider its relationship to the sun. The structure needs to be located and oriented to ensure that areas requiring the most solar exposure will be correctly positioned in reference to the sun, and vice versa for those areas that need the least. Okay, so where do I get this information? Good question. There are a ton of government sources where you can get information for free. There are also places where you can get this information at a price. You would bill your client for this. This would be something that you would factor in to your bid for your services. You could either list it right out as to what it is, or you could factor it into different miscellaneous things that you'll need, because it happens, right? I mean, if you're working on somebody's house, you should not be paying for this directly. This should come out of the fee that you're charging the client. Okay, and then there's this great link down here that tells you how to do it yourself. If you want to create your own sun path based on the free data that the government puts out there, you can also do that. And the link to that is right here. Okay, so now we have our information, and we can now begin to look at this, not just two-dimensionally, but three-dimensionally. Keep in mind, the southern exposure allows a maximum amount of solar exposure. Basically, the house, that face of the house if you're in the house looking out, you are, let's just make sure this is, I'm turned around here. Okay, so you're in the house, right? And you're facing north. And the sun is exposing south. Trees can block your exposure. And as we talked about, in the summer, the sun is going to rise in the east and end up higher in the sky, therefore create shorter shadows. But also, because at that point the earth is closer to the sun, it's going to be hotter. It's going to be hottest. So if we draw lines to where the sun hits, what can we do to mitigate that exposure, especially in warmer climates? And then conversely, in the winter when it's cold, how can we take advantage of that to reduce our footprint? That is part of the basis of sustainable design. This is if you're considering solar, and I highly recommend everybody that is in sustainable design consideration go for look at solar. It has significantly come down in cost over the years. It is one of the best ways to be a green, sustainable structure. And you can see based on this how many hours per day per square meter can you collect on a solar panel to power your house. So you want to be able to determine that. Obviously, if you are building a house anywhere in the South, especially in the Southwest, you're going to have access to a lot of potential solar resource. However, you have to be careful because you can overload the system too. Georgia, where I'm located, is very ideal for solar collection. And then you can see as you start to get further north along the coastline, in the upper Midwest here, you collect less, and that is something you have to consider, because what's going to happen is these areas get less sun, and you're going to see the least amount of sun you can get is Alaska, and you would need to supplement what you're doing. So you would want to consider that. What happens if the sun is not producing enough resource for what the house needs? Conversely, you can also design the house to fit what's available. All right, so you have a choice there. When you're designing, can you get the square footage down enough that the watt hours needed can be controlled? How do you size the panels? And if not, then what third choice, the least sustainable, is what is the supplemental source for when the solar resource, the sun, isn't shining because the clouds are out and it's raining and has been for 2 days, right? You're not going to collect. You'll collect some because the sun still gets through, but you're not going to collect what the house needs to run. How do you supplement or augment that on those days? Storage batteries. I know Tesla has a wall system. There are other. Whoops. Just noticed you can't read that. There are other companies now that are getting more into the market besides Tesla. It's just Tesla's one of the most well known. It's one I know the best. And but there are storage systems so that you can collect it and then store it for when you need it. Also, power companies have customers that they buy their excess during, when they're collecting excess, they'll buy it and resell it. But it's very, very hard to get in those programs. Those are pretty much always full. Your clients might get rebates for purchasing these systems. It's just really a matter of doing a little bit of research to find out. Sun altitude and azimuth, and that just has to do with where is it in the sky and how does that affect where it hits the house. And that varies for every latitudinal and longitudinal point. So there is no, hey guys, this is it. There's a, hey, you got to go back to those resources and do your research. So one of the things we consider in sustainable design is overhang and baffle protection. And there's a whole bunch of Frank Lloyd Wright houses here because he used a lot of overhangs. He very much designed for the sun. And so you want your roof overhangs and baffles to be designed to allow for the maximum amount of sunlight in winter and the minimum amount in summer, unless you're designing in a climate that is the reverse of what most people in North America experience. For instance, the closer you get to the equator, it doesn't matter summer or winter. You're going to want year round. And so that kind of makes it easier. The further north you go, you're never going to get hot enough, but you are going to get very, very cold. And so you have different considerations. But in the Goldilocks zone, this is the advice to go for. And here are some examples. how to do that. Okay, so here's the sun, noon at the summer solstice, the first day of summer, at this latitude. And so we have created, based on where the sun angle is, so this azimuth, which is what this is 79 degrees for this latitude. We know the sun is going to come down at this angle. This overhang, which is quite large, would be adequate to block the sun from directly coming in the building. If you move this over, you're going to start to get sun coming in. Okay. And you can see now we're at fall. And the azimuth of the sun coming in changes, but now that we're getting into fall, this is okay. If it's not, then we just extend this out further. And then noon December, now we're getting maximum sun and minimum coverage. So this is sort of our compromise. We're not going to fully get this in here, but we got a lot. So this is really going to warm up the room. The sun is going to, in December, the first day of winter, the sun's light is going to come in and really warm this space. Now it changes with the latitude, right? So where you are in latitude matters. So that's why you want to know this for sustainable design. Okay, we're going to stop here and continue in the next video.